My name is Van King. Today's topic is Franklin-Ogdensburg minerals, a tale of micromounts, fluorescents, gems, giant crystals, and species. This is a particularly precious specimen. It is from John Ebner's personal collection of antique micromounts. It is a micromount of Hancockite that was made by Elwood P. Hancock, the man who found it in 1898, and it was named for him. It's also with golden yellow axonite Mn. Some of the crystals of Hancockite can be very platy in appearance. This is actually sort of a parallel growth cluster of Hancockite, also with axonite Mn. Rare minerals are famous from Franklin, but the common minerals are actually rare and sometimes rarer than the so-called rare species. This is a cluster of purple cubic fluorites from the Buckwheat Mine. It's in dolomite. Tourmalines are known from the district. This is a specimen that was labeled Fluorite. Dark brown tourmaline. It's with white calcite matrix. The dark material with it is a mixture of pyrrhotite and other sulfides. There is the suspicion that this particular specimen may not be fluorite at all. It may be a rare species called fluordravite, still a tourmaline, but one which has yet to be reported from the district. This particular specimen is being investigated to see if it will add to the species list of the location. The typical fluorites that are genuine and unquestioned are these ones that are an olive green. They're in Franklin marble. They're not from the ore deposits precisely. They are from the rocks that surround the ore deposit. The black little flakes on the surface of the fluorite and the marble are graphite. Fluorite was first discovered at Franklin, New Jersey. I told you about the fractures. Remember way back in the mine? Well, this is a specimen of a fracture on pinkish red, black zinc ore with white calcite. And on the very top, you'll see there's a brown fracture surface that has been stained. And in it, there are some orange crystals of colloquite. This is the typical occurrence of many of the rare species at the Sterling mine. A close-up of specimens of colloquite show that they have this diamond-shaped termination and a very wedge-shaped kind of section. They're closely spaced together. Some of the druzy white crystals on the surface are calcite. Much to the consternation of many mineral collectors, there are lots and lots of species that look like colloquite or any of its relatives. This is the species Holdenite that was first found at Franklin, New Jersey. It's a specimen from Sterling, and it is a rosy pink color. It begins to look like and be almost indistinguishable from colloquite and several species. There's an orange-brown mineral, sarconite, found on fracture surfaces of the Sterling mine. This is a large piece. The entire surface is a fracture where this mineral formed on top, and we'll look at a close-up of one of the clusters on this surface. Here we see sarconite with a creamy interior and a transparent, gemmy, but dark zone termination on either side of the sarconite. It's on some franklinite, calcite, and other species. Associated with alactite, sarconite, holdenite, or sometimes colloquite, this specimen is also a fracture surface. The botryoidal irregular crystal groups on the surface of the fracture are calcite, and we'll look at a place on the top side, top left-hand corner of this specimen to see what alactite crystals look like. The crystals are purple red, brown, brownish red, and may even be bright red. And the shape, you can see, almost looks like a barite or a similar sort of mineral. Most of these are micromounts, however. Another color for alactite, these are with rhodochrosite, pink, about 5 centimeters long, and here we have a close-up view where the crystals are about 2 millimeters in maximum length. This mineral, Adamite, is a rarity. This is about one of the best specimens known. There are probably only a handful of specimens that there are, and it is associated with black heterolite, a manganese oxide. The Adamites from this location do not fluoresce, although they do fluoresce very brightly from places such as Mapimi, Mexico. Continuing with the species that are brown, red, etc., this is the silicate Alleghanyite. These are among the best crystals of the world at this location, and this is a particularly fine one that the Franklin Mineral Museum owns. The surface of the vein is covered with franklinite crystals, calcite. Again, some species which are common in many, many locations are a great rarity at Franklin. This one is no exception. This is a small crystal of anatase, 500 microns tall, and this was photographed by Ralph Thomas many, many years ago when you had to use film, and the bellows that he used to get this kind of magnification was nearly 3 feet long. However, he did capture a wonderful photograph of it. If you want to have a complete collection of Franklin minerals, this is one of your key species, anatase. Some of the minerals that are found in the marble at Franklin. And this one also satisfies because it is a feldspar. This is a gray, probably graphite-included anorthite, nearly N-member, not one that is rich in sodium, but almost entirely calcium-rich. Whole rock view, and the crystals are in marble that have been broken out. Probably this specimen came from the Nichols quarry, which was used to produce flux for the mine in order to melt the ores and refine them. Some of the rarest of the species are also very hard to identify. And you say, wait a minute, nicoline, isn't that relatively common? Not really. Most of these species were found in the 1890s, and the lower central portion of the specimen shows a kind of bronzy brown richness of nicoline. However, there's all this silvery white material around it. It is not nicoline, and those are the hard species to identify. You see that there are little zones inside of the specimen. Note that this has purple fluorite on the extreme right edge of the specimen and also in the center. That's an important thing to realize because nicoline rarely occurs with purple fluorite. If you look at a broken section of this assemblage, you see the black druzy material on the extreme right and the extreme left is a micaceous mineral called stiltnomalane. The metallic material that dominates the central portion of the photo actually is zoned. The minerals form a pattern. So if we start at the lower right, you'll see that there's sort of a little layer of silvery white mineral that is not exactly attached to the spherical circular mineral in the field of view. That material is sapphirite. The vein that is loose is in contact with a coating that goes all the way around every one of the other dark gray minerals in this picture. That is Gersdorfite, another nickel mineral. On the interior of these, the next mineral in is dark gray, and that is Para-Ramelsbergite. And the very interior, you'll see a silvery white mineral, Ramelsbergite, and the very nucleus, the very central portion, has a brown metallic grain of nicoline. This pattern is so characteristic it can be used to identify the various minerals in specimens that you might encounter. We have a polished section showing the same sort of thing, perhaps a little easier to see, except there's no sapphirite in this particular one. You can see a granular coating following the top edge, not really touching the dark gray metallic mineral. The outside edge is Gersdorfite. The black matrix is stiltnomalane. Go inside, you see dark gray Para-Ramelsbergite, and silvery gray, light-colored Ramelsbergite. This sequence of events is consistent. There are crystals within the nickel-rich assemblage, but it doesn't have nickel in it. These are cobaltite, crystals that are dodecahedral. They are on the druzy stelpnomelane, the micaceous mineral, very fine-grained in this piece. And there are no other cobalt-rich minerals in the field of view. It's going to cost about $25,000 to print the book, and even if you send us $1, if 20,000 people did that, we would have $20,000. So whatever you can send, we'd really appreciate it. Thank you very much.